In this video, I'm going to show you how you can identify the reactants and products in a chemical equation, how to use a chemical equation to determine the number and types of atoms in a molecule, and identify subscripts and coefficients, and also how to know if an equation follows the conservation of matter. So in a chemical reaction, reactants form or react to form products. So reactants react to form products. Reactants are written on the left side of a chemical equation, and products are written on the right side of a chemical equation. So here I have a chemical equation. CH4, which is methane or natural gas, reacts with oxygen. Those two reactants, these are my reactants, react to form carbon dioxide, CO2, and water, H2O. These are my products. And so in a chemical equation, we use coefficients to show the number of atoms or molecules reacting, while subscripts are used to show the number of atoms within a molecule. So a coefficient is something that's written in front of a molecule. So this 2, for example, is a coefficient in front of oxygen. This 2 is a coefficient in front of water. Subscripts, sub means below and script means to right. So these little numbers below certain atoms are subscripts. So for example, in CH4, this subscript 4 means there are 4 hydrogen atoms. Now there's no subscript for carbon, the C right here, because there's just one. So there's 1 carbon and 4 hydrogen. This subscript here for CO2, this 2 means there are 2 oxygen atoms and just 1 carbon atom in a molecule of CO2. So let's kind of visualize this same equation. CH4, there's 1 carbon atom and there are 4 hydrogen atoms, and there's just 1 CH4. We don't need to write a 1 coefficient there. That's not necessary. We just know that there's 1 if there's nothing written in front. And so we see that there's 1 carbon atom, this big black circle, and then these 4 hydrogen atoms attached to it. 2 oxygen atoms, meaning there are 2 molecules, 2 oxygen molecules, 1 here and 1 here. And in each oxygen molecule, there are 2 oxygen atoms. So here's 1, 2 atoms of oxygen to make up 1 molecule, and here's 1, 2 oxygen atoms to make up the second molecule. For CO2, there are 2 oxygen atoms and 1 carbon atom. So here are my oxygen, oxygen, and carbon. And H2O, that's water. Water has 1 oxygen atom and 2 hydrogen atoms in it. And we have 2 of them. So here I have oxygen and hydrogen, hydrogen, H2O. There's 1 of my molecules. And here I have H2O. Again, 2 water molecules. And we learned that matter cannot be created or destroyed. That's the conservation of matter. So since matter cannot be created or destroyed, the number of each type of atom on the reactant side should equal the number of atoms on the product side. Right, so since nothing can be created or destroyed, the number you have on the reactant side and the number of atoms you have on the product side should be equal. The same matter is still present, it's just rearranged. So nothing goes away, but it does rearrange. These atoms break bonds and form new bonds. When equations show the conservation of matter, when they show that nothing was created or destroyed, we say that those reactions are balanced. So if I were to look back at this example of methane reacting with oxygen to form carbon dioxide and water, if I were to count the number of each type of atom on either side, I have one carbon atom on this side. I have a total of 4 hydrogens. And for oxygen, since I have 2 molecules of oxygen and each molecule has 2, I have a total of 4 oxygen atoms. And that's on the reactant side. If I looked at the product side, this side here, and I looked at the atoms that I have on this side, I have 1 carbon atom. For hydrogen, I have 2 atoms of hydrogen in each molecule of water, and since I have 2 molecules of water, that's a total of 4 hydrogens. I have 2 oxygens in CO2, and in each of the 2 water molecules I have 1 oxygen, so that's another 2 for a total of 4. So the number I have here of each atom, and the number I have here of each atom is the same. So this equation shows the conservation of matter.